Thank you so much. Good afternoon, everyone. I'm Shriman. I'm representing ICL Singapore chapter here as a memberships committee chair for the year 2021 and 22. I also work as head of ICL Sales at IESVE Singapore Pte Ltd. Without further ado, let's continue with our topic. The topic for the today's session is digital twins for the built environment. Over the last couple of years, we have been seeing that the term digital twins has been booming a lot. As the Industry 4.0 continues to drive the digital transformation and adoption of new technologies and processes across industries, the digital twin concept has garnered serious attention in recent years. And the use of such technology is predicted to continue to grow rapidly over the coming years. As a result, the market has been flooded with providers claiming to offer their digital twin solutions to a variety of ends. But how useful are they really? And how useful are they specifically to the built environment? And how can prospective users cut through the babble of digital twin marketing speak to make sure that they get the right technology that will be of true value to them? Hopefully, by end of this session, we all will be in a position to better understand what digital twin values are to be taken forward for the built environment. Before understanding digital twins, or rather than deep diving into the concept, let's understand the landscape of building performance simulation today. The industry today has progressed towards making energy simulation modeling as a common factor that goes hand in hand during the design stage along with multiple stakeholders of the project. A complex building performance simulation includes developing the model of a building, understanding the schematic of the HVAC systems, and analyzing them to optimize them. Further to it, the analysis is presented to the councils and rating systems to rank its performance as compared to the reference standards. In general, when we perform an energy modeling exercise to comply with the rating system, we do a lot of references to the base cases. These base cases are established basically by the local governing standards, and these basic cases revolve around the building construction typology, the envelope values that you will be using, the lighting systems that you have to use for your building, the space conditioning, the external windows, the ventilation systems, and to a greater extent, the profile of the building as well. So referring to all these base standards given by your local council, generally a base case is developed to predict the building energy consumption. Equally, when the improved case is produced, the improvements will certainly happen over these variables and above and beyond these variables. For example, during the design stage, an architect, along with the ESD consultant and the mechanical consultants, try to focus on building new construction materials that has an enhanced U value. A lighting designer will try to bring in the best lighting system, in fact, uses LED lightings and daylight sensors and occupancy sensors to kind of save energy in the lighting and energy consumption. The air conditioning systems are generally equipped with the better air distribution system. The chillers are used with the high performing chillers. The external windows, the glazing systems are designed to have so that they have low SHGC and as well as a lower U value. The ventilation systems are augmented with passive and mechanical ventilation so that you have better energy savings. So putting all together and improvising your design over these elements helps you understand where your building stands with reference to your base benchmark. The base benchmark which has been given by your local governing standard, and the relative comparison between these two buildings, and making sure that your improved case is better off by certain percentages will enable you certain points when you apply for the rating system. Now, this whole process of energy modeling, specifically when complying with the green building standards, is very interesting. Here is a quick sequential process of what happens in an energy modeling. So initially, even before, this is during, especially in the early stages of design, even before when you have a model available. So what you do is, like, preliminary using the tools, energy modeling tools, you will be able to do a site study and a climate analysis. And this is essentially to understand what are the natural resources that are available. And accordingly, you will tweak the orientation and do an orientation optimization of your building. I mean, be including, the window wall ratio distribution across the building, or providing of the shading devices, which direction would make more sense. That's the kind of layout analysis that you do certainly for your building. And the next would be an optioneering, where you will be trying to optimize your mechanical systems as well, in terms of what is the HVAC schematic, what kind of a air distribution system would perfectly make sense for this kind of a building. And all this put together, and understanding the overall energy consumption, but not foregoing the occupant's comfort, you also do a daylight study to make it sure that there is enough daylighting harvesting, and there is no glare for the building. So typically what we see is, like in the energy modeling processes, from step number 1 to step number 5, there is a continuous iterations that happen to make it sure that you reach at the best optimized energy consuming building. However, the pending stuff, or the way ideally the building energy modeling is expected to end, is that during the commissioning stage and the handover stage, the energy model that you develop becomes the starting point for your FM team and the operational staff to understand the spectrum of the building operations and optimize the operational performance throughout the journey of the building. So this basically is the missing gap in the industry at the moment, and this is being covered by digital twins. Now, let's focus on understanding digital twin definition in a broader perspective. A digital twin is essentially a virtual replica of a physical component or entity, and the dynamics of that particular component or entity. So this live twin gathers data and uses physics-based simulations to create a data-rich living, breathing 1:1 model that behaves in the same way as its real-world counterpart. This means a digital twin can have many useful applications, ranging from initial concept and design through to the continuous monitoring, FDD, fault detection diagnosis, and maintenance planning and testing of new ideas for what-if scenarios. So what distinguishes a digital twin from any other digital model or a replica is its connection to its physical twin. Digital twins bring a wealth of useful applications across the construction market and asset life cycles, acting as a bridge between the physical and the digital world. As sensors become more affordable and more smaller, the ability to gather, process, and communicate information increases, making the interface between the two worlds, the digital world and the physical world, absolutely invaluable. One area where digital twins can have major impact is the decarbonization of the built environment. Now let's focus on understanding what's a digital twin definition for the built environment. In the built environment, digital twins acts as a live building models or digital models of physical buildings and communities, and can function as a problem solvers, providing decisional support, information needed to improve asset performance, influence future building design, and reduce risk. They provide a one-on-one representation of building in use, replacing design assumptions with real data and physics-enabled science-based simulations to result in a calibrated or operational model of the building, which updates and responds in real time. Smart energy communities, zero carbon districts, and positive energy blocks are among the labels used to identify district and community level schemes. Other environments with similar characteristics of a bounded complexity, including islands, university campuses, airports, and large real estate developments. Such projects represent an important upward scaling of a climate action from individual sectors to a more holistic view that can encompass integrated energy systems and broader behavioral and social changes. Community scale projects are the place where broader policy objectives and practical programs for transformation can come together. Cities will become clusters for smart energy communities that can exploit the benefit of new energy systems. Now, let's understand digital twin at a building level. I'm sure in our built environment journey, we all have come across this terminology called BIM. BIM stands for Building Information Modeling. BIM enables us to construct a building digitally before stepping on site. And next is BEM, Building Energy Modeling. Building energy modeling enables us to predict a building's performance much before operations. Digital twins Certainly, it is one trend which is steadily gaining momentum within the buildings and the construction sector to transform the way we design, build, and also operate our buildings. However, the concept of digital twins is not new at all. NASA and manufacturing units have been using digital twin technology for some time now, but it's only in the recent years that the technology has begun to gain traction across many different industries. Market value for the digital twins in 2019 was about close to $3.8 billion. And the predicted value for the digital twins in 2025 in the construction sector is about close to be $35 billion. In several implementation of digital twins for the built environment, there is often too much focus on 3D visualization. I'm sure a lot of us relate to the building with the way it is represented. However, a lot of effort is employed to create a very realistic, very appealing virtual models. Although the visual aspect can be important in some contexts, such as architectural rendering, I believe personally it's mainly aesthetic. It is not fundamental, and other key aspects of the digital twins are equally more important. The main point of a digital twin is that it should be useful and fit for purpose, that it has a goal and that it helps its user to achieve a goal. For example, improving a product, making a prediction, or simply exposing the characteristic of a physical asset that are not immediately visible. The objective when building or defining a digital twin should be to hone in on those features of the digital assets that are useful for the analysis at hand. Two cases that we can potentially discuss is about a portfolio of buildings that are already existing on the at the community level, or design of new buildings. Now let's talk about the first case where the portfolio of buildings come into play. If the purpose to build a digital twin of a portfolio of buildings, and the goal is to decarbonize the portfolio, to reduce costs, and also the information available is only data from the sensors, IoT devices, and smart devices, then a digital twin can be built that uses only this information, and the visual component can be safely ignored. However, in the second case, where we're talking about building a digital twin for a new building, then of course we need a much more details representation of the building geometry, building systems, and surroundings. But this would be in a different case. Both cases would qualify to be a very good examples of digital twins, but however, the purpose to which they serve are totally different. A digital twin based on physics-based simulations rooted firmly in building science still allows architects and engineers to make predictions, analyze options, and make decisions with a higher degree of confidence. Now, if you actually look into a physical asset, there are a magnitude of information that and multitude of information that's available, that's coming from the building. I mean, one of the primary source from which you can obtain the building data is basically your BMS systems. Okay, and there are separate meters for your gases, for your temperatures, for your communications, for your lighting, you have dedicated meters, for your site data, for your carbon, for your occupancy, for your electricity. A lot of information goes into a physical asset actually, or rather a physical asset would be able to give us a lot of information. So essentially, when you put this physical asset in a larger context, let's say if you're talking about a cluster of buildings, data management issues are significantly amplified in large-scale campuses or community projects, and a single digital platform becomes essential to ensure that data is converted into actionable information for multiple stakeholders. So I just want to reiterate the fact that a digital twins is basically an extension of an energy modeling where you again have to work with multiple stakeholders, and it's not just one game. So let's talk about how a digital twin matures over a period of time. Let's say you have a physical asset and you're looking at developing a digital twin. The most and the fundamental important aspect of the digital twin is about the reality capture. I mean, not necessarily from an aesthetics or a rendering perspective, but if you look into a reality capture, what's important is about understanding the geometry of the building so that you can create a 3D model, not an exact representation. I would always prefer to call it as an energy model in place of a 3D model. And the number two is, how do you tap in the data from the live building? It's more important that you take the data on a live basis from the building on a continual basis and get this real-time data integrated into your digital twin. And the third is the most important factor, according to me, is a two-way integration. The data analysis is not the end goal of a digital twin. The digital twin looks forward to go beyond the data analysis. Well, certainly you do a data analysis in the digital twin process, but again, what's more important is like the data that you garner or you take it from the live site is basically to analyze and again plug it back to the building so that your physical asset starts performing and the entire exercise of digital twin comes into fruition. Digital twins overview and the value proposition. I mean, quite often it happens that when we meet the developers and we sit across with them to make them understand the concept of digital twins, I've been always asked this question saying that, look, we already have a BIM model of our project. Like, how is that different from a digital twin? And with all due respect, I would say that, BIM is a fantastic source of a repository of information. But whereas fundamentally, digital twin goes up 2 levels of advancement there. So to put it in a simple manner, a BIM model is a detailed model that provides a central point of reference throughout the life cycle of a project. It is an important data repository which enables the visualization and management of building data and facilitates collaboration across the whole project team. Information is updated at key project stages. However, the BIM model remains very much a static representation or a snapshot in time of the building, based largely on design assumptions or construction documents. So the current BIM models do not include the dynamics of a live digital twin. Although there are some similarities with a digital twin, there are key distinctions. The addition of real-time sensors and big data combined with the power of physics-based simulation means that a digital twin has further reaching applications than a typical BIM model. A digital twin is not only looks like the building, it behaves like the real building, responding to the operational conditions and building occupancy to produce an invaluable operational asset. So that's exactly where I was saying that, it's not just about designing a building and making it sure that it performs according to the reality, but it is also about, the operation, the way it responds to the operational conditions, which are typically controlled by the FM staff on the ground. So it is the addition of physics-based simulation that makes this possible, as well as offering and the ability of filling the data gaps makes predictions on completely unforeseen scenarios and continually optimize the asset. So a digital twin is much more focused on building performance than a typical BIM model. Digital twins bring together the different technology elements mentioned, effectively provide a visual representation of the components and dynamics of a real object. Digital twins are characterized by their connection between real and virtual homogenization of data. So like I said, when we sit along with the developers to make it sure that, what is the end goal of the digital twins, it's more important for us to figure out a strategic definition for the digital twins. So, I mean, every asset owner has a different end goal when it comes to digital twins. So first important thing for us is to, when we sit and work along with the asset owner, it's important for us to derive the strategic definition of his view of digital twin. And eventually, over a period of time, that particular view changes and we influence the view. And also, when I say we, the built environment people who are working in the digital twins, they influence the view and bring the view into a right direction. So that's exactly where we embark on developing a digital twin development. So the good thing is, like, if you already have a model of the building and for the corresponding tool that you're using for the digital twin, the first process, the step number 1, where you are looking at digital twin development, doesn't really consume too much of time. You can straight away go to the second process where you're looking at data collection. So this data collection is basically the wealth of information that you will be getting it from your FM teams on the site. And this team will provide you with a lot of information like the building plans, basically your AHU, O&M manuals, basically the number of air conditioning systems you have, what is the typology of air distribution system, the lighting load, the energy bills, the monthly energy bills, and if they have any meter data, they do share that meter data. So now, taking all this data, what we do is, like, with the model that we have already developed in our energy modeling process, or maybe in the digital twin development process, we investigate the data to try to understand what is the difference between the operational gap, the performance gap, and the design gap. Now, typically, when you do such kind of an exercise, like in ASHRAE level 1 walkthrough audit, when you walk into a building, you try to understand the scheduling and the operations of the overall building assets. So similarly, in the data investigation part, it's quite prudent that you will be figuring out some data anomalies specific to a certain system, and that helps you to discover some of the missing energy saving elements in that particular asset. So typically, when you embark on the first step of digital twin development, it is essentially in the first 2 to 3 months of the timeline itself, you will be able to unravel a certain amount of energy savings owing to the assets. The next is data benchmarking, where you significantly benchmark your reference cases, or maybe the operational cases or the calibrated cases you can talk about. And then eventually, you will start introducing the energy conservation measures. And when you introduce the energy conservation measures in your virtual asset, what happens is like you will be able to ascertain that if you make any changes to the AHU, or if you introduce an occupancy sensor, what is the likely predicted energy savings in a course of next 1 year or 2 years with the current operating conditions. So that gives you an opportunity to discover the investment assessment. So the way it happens in the market is that you discover the energy saving conservation measures, you rank them in terms of the investments and the ROIs that it will create. And this gives an opportunity for the asset owner to make a decision as in which particular element he would like to make an investment. And possibly from there, what you can do is like, once you finalize on certain number of features, like the investment options that you want to invest on your asset, the implementation will happen, and the digital twin is upgraded to cover all those implemented aspects. Now, in an ideal scenario, and that's where the industry is drifting to, is that when you hand over and close out this particular project, you expect the FM staff on the ground to be trained on the digital twin technology, because they will be sitting on the building for a longer time, and they have to use this entire technology for the better purpose in order to save the energy. So the center point, what will be the deliverables and the desired outcomes of a digital twin, is that you create a high value digital asset, not necessarily from an aesthetics perspective, that can be used throughout the life cycle of the building. And you also create a working digital twin where you can try and test the ECMs before scaling them onto the physical assets. And of course, I mean, support the sustainability team. I mean, most importantly, this is one interesting trend that we have seen, is that most of the buildings are coming out with their own sustainability teams, and which are primarily focusing on energy optimization and a lot of what if scenarios that, you know, what happens if we tweak or we do the changes in the specific building. So when you create an operational digital twin, a virtual twin, this particular twin will help the sustainability team to make the investment decision options. Well, the outcomes could be very different. I mean, like, preferably, it's good to have technologies who can help you not only achieve this asset optimization, but also help you in terms of better represent this progress of your digital twins journey. The end goal is to ultimately have digitalization of the overall portfolio. The future enhancement, like, I mean, the next stage of the digital twins would be like, once you achieve the energy optimization, maybe perhaps the same model can be used to do an advanced comfort studies and the health and well-being of the occupants. And also, we have seen that digital twins have been often used for space changing and the future weather scenarios as well. So it would be very interesting to see that, you know, how just by creating a digital twin, not only from an energy perspective, but also from an operational enhancement perspective, how you can take the overall journey forward. Now, talking about decarbonization using digital twins, so far we've talked about energy optimization with digital twins, but the decarbonization using digital twins is altogether a different scale. It's one of the process which happens in the entire digital twins technology. But what's very interesting to see is that, you know, when you collect the data and when you start investigating and analyzing the data and build the virtual twin, what happens is like you virtually test the energy conservation measures. And what's even more interesting is that, you know, you will be able to figure out what is the most accurate energy conservation measure that will go really well with your building. And once you calculate the ROIs and zero in on the investments that you make on the energy conservation measures, that's exactly where, before even investing on the renewables or before even doing retrofitting, there are certain commissioning features that will help you uncover some energy savings. So that's where A holistic approach of energy optimization is best represented with a narrative of a leaking bucket of water. Instead of keeping the tap on and using expensive water, it's best to seal the leaking holes first. So retro commissioning is the first step where you can systematically identify and enhance performance without any alterations or upgrading works. These zero or very little capital expenditure items include examples such as recalibration of sensors and resequencing of controls. And at least from the works that we have done or the experience that I have, I've always seen that retro commissioning is an excellent opportunity for the asset owners, that they don't really have to make a significant investment before they uncover some energy savings from their own asset. The next step is the retrofitting. Retrofitting, on the other hand, usually involves low to high capital expenditure, as it involves upgrading existing building components, such as adding occupancy sensors if you don't have already, upgrading lighting fittings to the LED, and upgrading the chiller system, which is on a high side we are looking at, and so on and so forth. And after trying all the options of retro commissioning and retrofitting, only after all these measurements, we can look at exploring renewable energy to reduce the remainder energy consumption further. So the scope of digital twins goes beyond individual buildings. A digital twin can encompass multiple interconnected buildings or communities to simulate how things will work, look, and interact in a huge range of different scenarios. This can allow stakeholders across the built environment to better manage assets and services, track their real-time efficiency, maximize utilization, minimize energy use, and more to revolutionize how we design, build, and operate, not only at the individual building level, but across the entire built environment. Now, one of the main reasons the digital twins are seen at a large scale is because earlier, if you have to do or if you have to include multiple buildings to work together, or maybe that multiple buildings are not necessarily a residential building or a commercial building, but there could be a different typology of the buildings. Like, for example, there could be a wastewater treatment plant, there could be a public green spaces, there could be a hospital, there could be an electric vehicle stations plant. All this to club together and to work them together, without using any software support for the digital twins, is actually a process in itself. And it would require a close coordination between multiple stakeholders. And needless to say that, when you have multiple stakeholders involved in this process, the time consumption is significantly higher. So a digital twin is perhaps an opportunity for us to discover what can be done virtually and then scale it at a physical level. And that's where we have seen that in the projects where I'm working, at least, is that quite often the decisions are coming at a community level, and in some of the areas where we are working, the decisions are coming at an individual building level. So there could be two approaches when it comes to building the digital twins. The first is at a community level, where it's basically a top to bottom approach. A community by large takes a decision. So there's a very famous project in Australia, which I'm working right now. Unfortunately, I can't disclose the project name. But the community by large has taken a call that they will be developing a digital twin for the entire community that they are serving. So very interestingly, what happens is, like, first we start at a community level. We take the group of buildings, maybe about 300 or 400, and try to understand the behavior of the entire community by large. And then we identify those certain set of buildings which are the energy guzzlers initially, and we start working with them. And slowly, it just so happens that the process of producing the digital twins can go from community to a singular building level. On the other hand, where we are working with a group of developers who are very interested in terms of coming out with the digital twins for their own respective buildings. And we sort of work with the digital buildings, and then sort of this cluster of buildings can call up to a community of having a digital twins. So essentially, when you're working in the digital twin domain, you should possibly look at having a technology that can explicitly help you scaling from community to the building level and from building to the community level. Right, okay. Using digital twins to create zero carbon communities represent a scalable investment, whereby initial energy savings from the optimization of the controls and usage patterns can be reinvested into energy conservation retrofits and renewable generation. The analysis and simulation facilitates better decision support and the ROI from these ECMs is maximized, providing the most efficient means of decarbonization available. To summarize, the digital twin investment in a smart, sustainable buildings is basically is all about creating a digital twin which can support you in your operational stages of the building. So typically for the buildings which have energy models, they can straight away proceed with having a building digital model and calibrating it with site performance data. However, for the buildings which don't really have a digital twin or any sort of a model representation, the primary stage would be to collect the information from the building asset optimization team, get the building data, create the digital model, try to understand the energy consumption patterns, and calibrate the model such that your virtual twin becomes the at least the closest to the operational physical asset. And the next is to simulate the multiple ECMs, and then again rank those ECMs according to the investment options that you have, and then create a live digital twin which is continually used by your FM team so that they can create the forecast and the training. So overall, in the experience of the digital twins, what we have noticed is that there is a typical payback period of the initial savings is about 20 to 15%, and the typical payback period is within 1 year, and a 30 to 40% of future savings via investment in ECMs. So create now your high value digital twin assets to create a high performance building. Thank you, and I look forward to your Q&A.
Right. Thank you, Sriman, for sharing a very insightful presentation with us.
Yeah.
And ladies and gentlemen, we will now proceed to our Q&A sessions, and we have received quite a few. Let me start with the first one. A lot of energy models are created for green building certification. Do you mean to say that these models can be used as digital twins? Over to you, Sriman.
Yeah, absolutely. I mean, in fact, those models could be a wonderful starting time to create the digital twins, because let's say if there is a building without any previous contesting for green building certification, so they don't have energy models. So at least for the buildings which have already gone through the green building certification process, I'm sure they might be having energy models which are archived in the process. So what happens is, like, if you have decided to go with the digital twins, you can start from the same model. Perhaps the whole process of developing the model, the site building plan collection, all these steps could be skipped, and straight away you can start with this model. And what you can start look at doing is, like, you can look at doing it for the buildings, the existing data, and from there you can progress to your digital twins journey.
Okay, thank you.
Yeah.
We will proceed with the next questions. How about the old buildings that might not have an abundance of ongoing performance data?
Right, okay. This is the most frequent question that we get when we talk to the developers.
How can we secure the data for a year? For this, would it be too much of a wait time to install sensor and then monitor them for a year and proceed to develop a digital twin?
Right. Sorry, there was a voiceover, but anyways, I understood your question. You mean to say that, how about for a building which has to monitor the energy for a longer time to have a digital twin? Well, I would say that this is the most frequent question that we get, that how would the historic buildings, or maybe the old buildings which are 30 years old, 40 years old, who don't really have any smart systems or devices in place that capture the data on a time series level. I would say that, you have to pick up an energy modeling tool, and also a digital twin tool that can help you capture the time series data. Not necessarily for an entire year. Let's say if you can install an automatic meter reading at the site of your interest and capture the data for 3 months, right? Okay. Use a platform which can help you develop the balanced for the 9 months of data. And that's exactly where I would say that tools with AI and ML capacity, artificial intelligence and machine learning capacity, can bring in a lot of value addition. You don't really have to wait for an entire year to collect the data from the site. You can possibly measure the data for 3 years, for 3 months, and then produce the data for the balance 9 months, so that you have total 12 months of data with you.
Okay.
Yeah.
Now, we have another question. You referred to FM staff using the digital twins for operational efficiency. in your experience, how long would it take for FM to get hold of the digital twins energy simulation process?
Right. Okay, that's again a very interesting question and very subjective question, depending upon what the asset owner expects actually. So for the works that I have done so far, we have seen that, you know, when we conceive the process of digital twins, right, we ideally include the FM staff right from the day one of our discussions, so that we have certain nominations from the FM team. Like I said, every FM team these days is having a sustainability team in place, and there are a couple of energy managers who sit with us throughout the entire journey. And in the process, what we do is, like, you know, we kind of train them on the technology, and we also equip them to a point where once we kind of develop the digital twin, assess the energy conservation measures, and install those ECMs, these energy managers sort of use the digital twin tool to forecast and predict what are the sort of, you know, what are the kind of savings or maybe the energy consumption that they can forecast for the coming days, and what are the measures that they can take on the site. Yeah, I mean, for sure, it's a bit of a time-consuming process, because, you know, there is a process involved. We are looking at anyways in between 6 to 9 months of timeline, but definitely, if you can involve your FM team right from the day one, I'm sure that will be more effective. I do see. I see some questions coming. I see some questions coming to me. So can I respond to them?
Take those questions.
Yeah.
Sure. Why not? I'll read the questions, and then so that the rest of the audience can understand.
So maybe in the interest of time, I'll take three questions.
We have. Yep. Sure. Right. Yeah, okay. So we'll take the next one. Can you share with us use cases of adoptions of digital twins locally, if any? Yeah. Yeah. What are the challenges convincing the local BE community on adoption of digital twins?
All right, okay. The example that I can share, which is already in the public domain, is Nanyang Technology University. So this particular university, what we have done is, like, we have implemented digital twins as a concept, and when we have worked with the NTU, of course, honestly speaking, NTU was also very willing and receptive in terms of adopting the digital twins. So we didn't really see that much of a challenge in convincing them to go for the digital twins. But from your question in terms of a private market where, you know, where we have to go and tell the developers, I believe it's mostly in the hands of the ESD consultants or the sustainability consultants on the board. Because from my perspective, a lot of times, energy models that are created go archived, and it is very important for the sustainability consultant to educate the developer, telling that, look, we have already invested on developing a digital model, and if your operations team is going to completely rely their operations on the building operations manual, then the entire excess of energy modeling is not 100% you know, kind of achieved. So that's exactly where we feel that, you know, right now we are working with a lot of ESCOs, a lot of sustainability consulting partners, so that we go and also kind of educate in the market what is the need for digital twins, what is the need for extension of an energy model.
All right, thank you, Sriman Ora. We take the next questions.
Yeah.
Are digital twins limited to only the assets or building information? Or do you also consider the maintenance and management business processes as part of the digital twin?
Right, okay. Well, it's a very interesting question. So right now with one of our customers, what we are doing is, like, they are kind of, they are the asset maintenance and the management people, and they are not the asset owners, but they just only operate and manage the asset. And very interestingly, they have come to us saying that they're wanting to have a digital twin of their entire portfolio. And the only reason that they are trying to do is, like, they're trying to optimize their initial investment for the maintenance and the management of the asset. So I'm not sure if I have completely answered your question, but maybe this we can take it on a separate note, because I do see some complexity in this question with regards to maintenance and management business process. So are you talking in terms of sustainability investment by the external parties, or are you talking about the ground level facility management is something that I'm not clear at the moment. So maybe I can pick up this conversation on a one-to-one.
All right, so in the interest of time, we'll take the last questions. What kind of size or cost are the payback and percentage savings typical estimates based on? Is there a minimum viable size or cost?
Again, I mean, this is quite an open-ended question, actually. I mean, like I said, when we are talking about the benchmarks vary from country to country, building to building. So the payback period, I mean, like I said in my last slide, the typical payback period when you're doing only the retro commissioning is about 1 year with a 10 to 15% of savings. And when you're talking about the viable size of the cost, I mean, there are multiple cost parameters that are associated. A, investing on the digital twin technology. B, bringing the stakeholders in. 3, C, investing on the sensors, the automatic meter readings to kind of capture the data from the building. And apart from that, there are other aspects as well in terms of the ECMs that you invest. So, I mean, there is no linear answer for this. Yeah, I mean, obviously it will vary right from the asset size, and the minimum viable cost for the investment of the technology is very subjective to the technology provider whom you approach.
Right, okay.
All right.
So now, ladies and gentlemen, we have come to the end of our webinar session. So we will reach out to you separately for those questions that we have not been able to answer this time. And we hope you have enjoyed the session brought to you by IESVE Singapore chapter. Thank you, Sriman. And the next webinar session is at 1 p.m. This session is powered by IoT Asia Plus, and the upcoming topic is connected real estates and building. At the same time, you're welcome to visit the exhibition hall where we have over 100 virtual booths on exhibits now. Thank you once again for joining, and stay safe.